Okay, today we're going to talk about probability. So this is the introduction to probability. We're going to cover 4 integrated algebra standards. We're going to cover AS18, know the definition of conditional probability and use it to solve for probabilities in a finite sample space. We're going to talk about calculating the probability of an event and its complement, empirical probabilities versus theoretical probability, and we are going to talk about events that are equally likely to occur, if one is more likely to occur, and whether an event can happen or not happen. Okay, so vocabulary is empirical probability and theoretical probability, fair and unbiased objects, biased objects, certain events and impossible events, and complementary events. Okay, so let's first talk about empirical probability. This is it's an estimate of the probability that the event will happen based on how often the event occurred after collecting data or running an experiment. It's also called experimental probability. So the probability that an event happens is the number of times the event occurred over the total number of observed occurrences. Okay, so again, this is based on sort of collecting data. It's not based on any sort of theory. We're going to get into theoretical probability in a second. So for instance, if I gave you this survey, it says a survey was conducted to determine students' favorite breeds of dogs. Each student chose only one breed. So 10 students chose Collie, 15 Spaniel, 35 Lab, 8 Boxer, 5 Pit Bull, and 12 chose another breed of dog. And I asked you, what is the probability that a student chosen at random has a favorite dog breed that is a Labrador? Okay, so what I'm going to do is, again, I'm going to look at the number of times that event occurred. That's 35 students chose Labrador over all the possible things that happened. So the number of students in the survey, I can get the total by adding all along this row, which is 85. Okay, so this is an empirical or experimental probability. Now I could further go on and divide 35 by 85 to get, and round it to the nearest 100 to get 0.41. All right, so sometimes I want to leave it as a fraction. A lot of times I see probability as a decimal. Okay, and you can even put it into a percent by multiplying it by 100. So there's a 41% chance of a student who's chosen at random would say that Labrador was their favorite breed of dog. Theoretical probability is the number of ways that an event can occur divided by the total number of outcomes. This is it is finding the probability of events that come from a sample space of known equally likely outcomes. Another way of saying that is it's sort of theoretical in that we don't actually run the experiment. We sort of think about it in our minds. So a lot of times we'll be given problems like if we roll a dice, or if we take marbles out of a bag, or if there are 10 students out of a population of 100 students, for instance. That's theoretical probability. It's not from a certain amount of observation. Okay, so theoretical probability is, so to find this probability, we look at the number of ways an event can occur over the total number of outcomes in a sample space. So let's do an example here. So for example, find the probability of tossing a fair die, we're going to talk about fair in a minute, and getting an odd number. So on a 6-sided die, there's the numbers 1 through 6. Okay, so odd numbers are 1, 3, and 5. So the event of getting an odd number happens 3 times out of 6 possible times. I can reduce this to 1/2. I can put it in terms of a decimal, and I can even put it in terms of a percent. Okay, so I either say that it's 1/2, 0.5, or 50%. Okay, now remember, this is theoretical probability because it's not like I took a die and rolled it a bunch of times and figured out that it was going to be 3 times out of 6 times we got, or some other occurrence out of a total amount of rolls. I'm just thinking about this sort of in my head. I'm not basing this on any observation. I'm just basing it on the idea of a die. So in a die, the equally likely of outcomes is getting every side is equally likely to occur. All right, and that brings us to the idea of fair and unbiased objects. So, an object is fair when the different possible results have equal chance of happening. Objects such as coins, spinners, cards, and die are all considered fair objects unless they're otherwise noted. So when we say we flip a coin, we say that there's a 50% chance of getting heads or tails. That's a coin that's not weighted. So sometimes people will talk about a coin if it's unfair, if you're trying to cheat. You could use a coin that is weighted heavily on the, let's say, the head side. So heads is more likely to turn downward, and you're more likely to receive a tails. Okay, so that's a way to mess with the likelihood of a tails occurring. The same if you have a spinner. Let's say that you have a spinner and you label this section 1 and this section 2 and 3. Well, it's not getting a 1, a 2, and a 3 is not equally likely outcomes, because 1 is much bigger, and certainly 3 is actually bigger than 2. So the most likely event to happen with this spinner would be getting a 1. So that would be a description of a biased object. It's been tampered with or weighted to give one result a better chance of happening than another result. Okay? Now we assume, unless it's otherwise noted, we assume that the objects are fair and unbiased. For all probabilities, the probability of an event occurring is always between 0 and 1. There's never more than a probability in terms of a decimal. We can never have a probability of more than 1. If the probability is 1, then we call that a certain event. Remember, 1 is also 100%. So if the probability is is equal to 1, which is the highest it can be, it's called certain. Okay. If the probability is 0, it's called an impossible event. It can never happen. If the probability of event 1 is greater than the probability of event 2, then it's more likely to occur. So let's say I have something at a probability of 0.5. Another thing happening, the probability of it happening is 0.34. Then we say this event is more likely to occur than this event. Okay? And likewise, if they're equal to each other, we say that they're equally likely to occur. So the probability of getting an odd number, which is 1, 3, and 5, is equally likely to occur on a die as getting an even number, which is 3 out of 6 and 3 out of 6. Okay? So let's talk about this die again. Let's say it's rolled, and let's find the probability that the number rolled is greater than 2 and odd. So let's think about the numbers that are greater than 2 and odd. Those numbers are going to be 3, 5, and that's it. So we'd say that the probability is 2 out of 6, or 1/3. We could go on to say that that's 0.3 repeating, but when it's a repeating decimal, we often leave it in terms of a fraction. Okay, because we also don't want to put that into a calculator, because it's actually, we can't put a repeating decimal into a calculator. We can only put it as a fraction. All right, the probability of getting less than 4 and even. So there's only one thing exactly less than 4, so that's 1 out of 6. Greater than 2 and less than 4. So greater than 2 means it can't be equal to 2, and less than 4 means it's strictly less than 4, so there's only 1 out of 6 chances. The 3 is the only number that does that. Less than 2 and even. Okay, so less than 2 and even, well, there's no chance of getting a number that's less than 2 and even, because 0 is not does not occupy a space on the die. So there's 0 out of 6, or just 0. Remember, this is an impossible event. Less than 4 and greater than 3. So if a number's less than 4, that's 1, 2, and 3. And greater than 3, well, greater than 3 is 4 and 5. So there's no number that is both less than 4 and greater than 3. So again, this is 0 chance. So there's an impossible event. Okay, I want to talk for a second about a deck of cards, because some people who play cards will understand this, but a lot of students who don't play cards won't understand the questions that are asked about cards, and you really should, because there's lots of questions that are asked about cards, especially for probability. So a standard deck has 52 cards in it. And there's 4 suits. So these are the 4 suits that they have. These are called suits. The hearts, which looks like a heart. The clubs, which looks like a 3-leaf clover. The diamonds look like a diamond. Okay. And spades is this shape right here. It's a black suit that has sort of an upside down heart with a little triangle in its in this shape right here, okay? Or it's like sitting, it's an upside down heart sitting on a triangle is another way to describe it. It's kind of a weird shape. So that's what these are called. Make a note of it in your notes so that you understand how to answer these questions. Each suit has 13 cards. So there's 13 hearts, 13 spades, 13 diamonds, and 13 clubs. That makes 13 times 4 is 52. That's the 52 cards. There's the ace, which has an A on it. The deuce, which is a 2. A 3, a 4, a 5. These are the numbered cards. 7 and an 8. A 9, a 10. Now the jack, queen, and king are the cards with the pictures on it. So when you see picture cards, we're talking about jacks, queens, and kings. The ace is sometimes played as a low card, sometimes it's a 1, and sometimes it's played as above a king. Okay, but the picture cards, when someone's saying picture cards, they're talking about just the jack, the queen, and the king. The joker is not actually part of the deck of cards that you play with. It's included in the pack of cards that you get, but it's not part of the 52 playing cards. Okay, so there's always 4 of a kind. So there's 4 10s, for instance. There's a 10 in each suit. Okay, so let's start to answer some of these probability questions based on cards. From a standard deck of cards, one card is drawn. Find the probability that the card is a king of hearts. So there's always 52 cards in a deck. So how many kings of hearts are there? Well, there's 4 kings, 1 in each suit, but only one of them is a heart. So it's 1 out of 52. A red king. So there are 2 red suits, the hearts and the diamonds. So there are 2 red kings. So it's 1 out of 52 or 2 out of 52 or 1 out of 26. Okay. King of clubs. So a king of clubs, again, just like a king of hearts, there's only 1 of them. A black jack. Remember, there's 2 suits that are black, the spades and the clubs. So there are 2 black jacks. Oops, 1 out of 52 rather. Or 2 out of 52 or 1 out of 26. A 10 of diamonds, there's only 1 10 of diamonds. Okay, a red club. Now, if we recall, the clubs are a black suit. It's not a red suit. So there are no red clubs. This is an impossible event. 0 out of 52 or 0. A black 2. Again, there are 2 black suits. So there are 2 black 2s. So 2 out of 52 or 1 out of 26. A red picture card. So there are 3 picture cards in each suit and 2 red suits. So there are 6 red picture cards. So 6 out of 52, that reduces to 3 out of 26. And 26 is not divisible by 3 because 6 and 2 don't sum up to a number divisible by 3. So that is it. Okay. Okay, a complementary event A. So the complement of an event A is the event that A does not happen. Okay, so if events are complementary, it means that one is the event and one is the event that it doesn't happen. So for instance, if event A is rolling a 4 on a die, and event B is not rolling a 4 on the die, these are complementary events because one is rolling a 4 and one is having that thing not happen. Okay? Whoops, and these actually weren't supposed to be together. They're not equal to each other. The probability of A is rolling a 4 on a die. Well, there's one side that's a 4 out of 6 possible sides. And the probability of B not rolling a 4, well, there's 1, 2, 3, 5, and 6. Those numbers are not 4s. So there's 5 numbers that are not 4s on a die out of 6 possible numbers. Okay? So event A and B are complementary. Now, in general, 1 minus the probability of A is equal to the probability of not A happening, or the probability of A complement. So for instance, when A was rolling a 4, 1 minus 1 over 6 is 5 over 6, right? And that was the probability of not rolling a 4, okay? Another way of putting this, if A and B are complementary events, then the probability of A plus the probability of B is equal to 1. That's actually a better, so it's better not to have written this down. It's better to have, this is actually probably a better way of stating it. Okay, so the probability of rolling a 4 plus the probability of not rolling a 4 is 6 over 6, which is 1. Okay, so let's use that information to find the probability of the situations below. So again, we're drawing decks of cards. So the probability that the card is a heart, there are 13 hearts out of 52 cards. Okay, and this is 1 out of 4. Okay, so not rolling a heart, there's a couple different ways we could do this. We could say, well, not rolling a heart, picking a heart out of a deck of cards and not picking it out are complementary events. So I can take 1 minus 1/4 to get my answer. That would be 3/4. Or I could also think, you know, if 13 cards are hearts, well, that would mean that 39 cards are not hearts, and 39 out of 52 reduces to 1/4, or 3/4 rather. Okay, a picture card. So there are 3 picture cards in each suit and 4 suits, so there are 12 picture cards. So 12 out of 52 is the probability of getting a picture card. Not getting a picture card would be whatever 52 minus 12 is 40. So it's not getting a picture card is 40 out of 52. Okay, because these two things are complementary events, so they have to add to 1. Okay, pulling a 6 or an 8. So when I say this, when I say or, it means that it can be a 6 or an 8. Remember, a card card cannot definitely be both 6 and an 8. So there are 4 6s in each suit. Whoops, I meant to write. There are 4 6s in each suit and 4 8s in each suit. So probability of pulling a 6 or an 8 is 8 out of 52. Okay, and its complement is not pulling a 6 or an 8. So that would be 52 minus 8. So there are 44 cards that are not a 6 or an 8. So 44 out of 52. Right, and all of these can reduce. I'm just not taking the time to do that. And that is the last slide. So let's just review what we learned real quick. We learned about complementary events. Okay. We learned about decks of cards. So make sure you have this in your notes if you're not familiar with cards. We learned about events that were certain events, impossible events, things that are more likely to occur and less likely or equally likely to occur. Fair and unbiased objects, and theoretical and empirical probability. And that's the end of the lesson today.